We're given a quartic equation there, and we're told that 3 minus 2i is a root of that equation equaling 0. So I know the conjugate of that root, 3 plus 2i, is another complex root of that equation. I'm going to find the quadratic factor that goes along with those two roots by adding the roots together. So 3 minus 2i plus 3 plus 2i is 6. Multiplying those two roots together, so 3 minus 2i multiplied by 3 plus 2i, the 3 times the 3 is 9, the minus 2i times the plus 2i is plus 4, the minus 6i and the plus 6i cancel out, so I just get 13. And remember that the sum of the roots is minus b over a, so that's why I know my b is minus 6. And the sum of the products of the roots is c over a. So I know that my c term is 13. I know my a is 1 because I'm looking at just the 1z to the power 4 there. So that's part A done. An alternative for part A is I could have written them as factors. If 3 minus 2i is a root, then z minus 3 minus 2i is a factor. And similarly, z minus 3 plus 2i is also a factor. And then if you multiply those brackets out, you'll get to the same answer. Anyway, moving on to part B, finding the value of k. So I've got the quadratic factor I've just found, and I know that has to be multiplied by another quadratic factor to get a quartic equation. I know the squared times the squared is going to give the z to the power 4. More precisely, I know that 1z squared times 1z squared is going to give 1z to the power 4. The other thing I know about this extra quadratic factor is I know this has to be 17, because 13 times 17 gives me the 221. So I know this other quadratic factor has to have a z squared and it has to have a 17. I know it's going to have a z term as well, but I don't know what its coefficient is yet. So I've just called that az for now. And now I'm going to work out what that a is by looking at the z cubed terms. Because I know I would have, if I were to expand this out, I'd have a z squared times az, which is az cubed. I would also have a minus 6z times z squared, which is minus 6z cubed. And I was told in the question that I should get minus 14z cubed. So just focusing on those coefficients then, the a minus the 6 should equal minus 14. Therefore, a has to be minus 8. So I know this a is minus 8 now. Right, now to work out the value of k. K is the coefficient of the z term, so I'm going to focus just on, if I were to expand these brackets out, just the z terms. Well, I would have a 13 times the minus 8z, and I would also have the minus 6z times the 17. Those would give me the k terms. And 13 times minus 8 plus 17 times minus 6 is minus 206. So that's our value of k. So that's part B. Part C, we have to solve the quartic equation completely and show the roots on an Argand diagram. So I've just rewritten the quartic equation here as the product of its two quadratic factors with it equaling 0. I know the two roots that go with the first quadratic equation. I don't know the roots that go with the second quadratic equation yet, but I can find them by completing the square. So that's what I've done here. Just halved the minus 8, subtracted the minus 4 squared, plus the 17. The minus 16 plus 17 is 1. I've then subtracted 1 from both sides. I've square rooted the minus 1 to get I, and obviously it'll be a plus and a minus I, and then added 4 to both sides. So Z is either 4 plus I or 4 minus I. Those are the other two complex roots to go with the ones we were given in the question. And then just plotting those onto my Argand diagram. The 3 plus 2i is here. This is 3, this is 2. The 3 minus 2i is down here. Again, this is 3, this is minus 2. And then I've also put the 4 plus I. This is 4, this is I. And the 4 minus I there. So all 4 of those results are now on my Argand diagram.